Welcome to Schrödinger's Chat, the podcast where I explore the real science behind the biggest questions in the universe, as well as some of the quirkier science we encounter every day. I'm Anna, a sixth form physics student with a lot of curiosity and a passion for understanding how the world works. From the smallest particles to the largest galaxies, join me as we unlock the mysteries and wonders of the universe and explore how physics shapes the world around us. Today we're starting a brand new mini-series, and I'm really excited about this one. It's called Legends in Lab Coats. This is where we shine a spotlight on the scientists behind the discoveries, their lives, their quirks, and the breakthroughs that shaped our understanding of the universe. And this first installment is all about pioneers. These are the people who stepped into the unknown, who didn't just solve problems, but invented entire new ways of seeing the world. They were ahead of the science of their time and pushed forward with revolutionary new ideas. Without them, physics as we know it might not even exist. We've got three absolute giants today: Isaac Newton, James Clerk Maxwell, and Lise Meitner. Three very different people in very different centuries, but each of them opened a door to a brand new world of physics. So, let's jump in. Let's start with Isaac Newton. It's the 1660s, and England is in the grip of the plague. Cambridge University closes down, and a young student called Isaac Newton has to go back to his family farm, Woolsthorpe Manor in Lincolnshire. Most people are probably bored or scared. I mean, you can imagine, we've all lived through the COVID pandemic. But Newton? He basically invents modern physics. During his Year of Wonders, as it's now called, Newton worked out the basics of calculus, started experimenting with light and optics, and began developing his law of gravitation. That's a better to-do list than most of us manage in a lifetime, never mind in a lockdown. Newton is one of those scientists where the more you dig, the more you realise just how much he started. This is definitely true for me when I was doing some research for this episode. He really contributed to just about everything. He didn't just write down a few equations, he reshaped physics in ways that we're still using today. First, his laws of motion. These sound simple, but they were revolutionary. They gave us the first universal description of movement. They're kind of like the grammar of physics. Whether you're talking about cannonballs, planets, or ice skaters, these rules apply. Before Newton, people like Aristotle thought different rules applied to the heavens and the earth. But Newton debunked that idea and developed one set of laws for everything. The first law is that a body will remain stationary or continue moving at a constant velocity unless acted on by a resultant force. The second law, which most people know as F equals ma, but a better version of it is the force is directly proportional to the rate of change of momentum. And the third law, if an object A exerts a force on an object B, then object B exerts an equal and opposite force on object A. Then came gravity. He realised the same force that pulls an apple down keeps the moon in orbit. That idea that the Earth's everyday physics also controls the cosmos was mind-blowing at the time. Suddenly, the whole universe was governed by one invisible force you could describe mathematically. But Newton wasn't done here. He also invented calculus, independently of Leibniz, although they did have a very nasty feud over who did discover it first. Calculus gave us the tools to deal with things that are always changing, like velocities, accelerations, and planetary orbits. Basically, modern physics would collapse without it. Newton had a wild side too. In optics, he argued that light was made of little corpuscles, tiny particles. At the time, most people thought light was a wave, but Newton's experiments with prisms showed that white light splits into a rainbow of colours. He was the first to really show that colour is built into light, not something added by glass or surfaces. Even though we know now that light has wave-particle duality, his particle idea was surprisingly ahead of its time. Oh, and did you know he was involved with the development of the telescope? The original refracting telescopes used lenses which gave blurry, rainbow-edged images. Newton thought, what if instead of lenses we used mirrors? He built the first practical reflecting telescope, which was compact but very powerful, and this design is still the basis of most big telescopes today, including the Hubble and James Webb Space Telescopes. Not bad for a DIY project in the 1660s lockdown. Newton also had his share of more eccentric projects. He was obsessed with alchemy, biblical codes, and secret numerology. Not all his ideas were brilliant, but when it came to physics, he was basically centuries ahead of everyone else. Newton wasn't just a brainiac, though. He had his quirky side too. He was famously grumpy and had epic rivalries with fellow scientists. In fact, his rivalry with Robert Hooke was genuinely an extreme rivalry, and the story is pretty epic. Settle down and listen to this absolutely crazy story of scientific rivalry. It all started when Newton published his first paper on the nature of light in 1672. This is where he presented his idea of white light being made up of all the colours on the visible light spectrum, and he also theorised that light was made of particles. In contrast, Hooke, who thought light travelled in waves, and many other scientists in the Royal Society, really contested this idea. They were not at all fans of Newton's suggestions. Now, Newton retaliated and was naturally very defensive of his work. Since Hooke was one of the main critics of his ideas, the rivalry started between the two men. From here, it basically just escalated. In 1673, Newton even threatened to leave the Royal Society, claiming that Hooke had better access to resources for his research than himself. In fact, at the time, Newton was actually the underdog. Hooke had already contributed a lot to science, was the Royal Society's curator of experiments, and had a much bigger reputation in the scientific community than Newton at the time, which all probably stirred up Newton's resentment for him. The next event in Newton versus Hooke was when Hooke accused Newton of plagiarising his ideas about light from his journal Micrographia in 1676. This time, Newton responded in perhaps a more sensible way and decided to keep away from the public for a bit to protect his ideas and not be accused of stealing anything else until he wanted to present something. The next issue that arose was also to do with plagiarism. In the mid-1600s, understanding gravity was all the rage in the scientific community. And yes, people were thinking about gravity before Newton. They knew there was some force of attraction, but how it worked was still a mystery. Now this is where the rivalry became even more severe. So Hooke had some ideas of how gravity might work. He thought there was an inverse square relationship between gravitational attraction and the distance between two objects, and that gravity was a universal force. He told these ideas to Newton in a few letters which he wrote in about 1680. Funnily enough, these two ideas made an appearance in Newton's Principia, which contained his work on gravitation and was published in 1687. Coincidence? Well, there was one thing that separated the two men's work. Hooke hadn't done the maths to prove his idea, but in 2 years Newton did. Still, Hooke claimed Newton would not have come up with the inverse square law without what he had already proposed in his letters. Newton bitterly disputed this accusation, and claimed that the information in Hooke's letters didn't actually mention anything that would have supported his mathematical analysis anyway. Believe who you want, but either way, Hooke's accusation did nothing to help his already fragile relationship with Newton. With the publishing of Principia, Newton's popularity grew, but Hooke's fame faded away, especially after his death in 1703. Also in this year, Newton became president of the Royal Society. During his time in this role, the only known portrait of Robert Hooke mysteriously disappeared. That is, there are no longer any portraits that have been authenticated as definitely being of Hooke that exist. Now, whether it was a coincidence or Newton destroyed it is still disputed to this day. The fact that Newton had many other rivalries, the other most notable one over calculus with Leibniz, has led many people to think that Newton was responsible for both the portrait incident and stealing Hooke's work. However, entries from Hooke's personal diary show that Hooke was prone to starting fights with other scientists, so other people argue that he is to blame. Anyway, whilst the two men never achieved a friendly truce before their deaths, both are recognised today for their work, with Hooke even carving out his own legacy, free of Newton controversy, as in biology he is credited with the discovery of cells. Newton also kind of cleared it up in a letter to Hooke when he said his famous, "If I have seen further, it is by standing on the shoulders of giants." Perhaps this was a way to acknowledge the fact that his ideas had been influenced by Hooke's. Whether it was to do with Hooke or not, I think his famous line still serves as a genuine reminder to recognise the importance of collaboration and the reliance on past knowledge in any field. Okay, so Newton may have had a bit of a temper, and perhaps an issue with copying, but you can't deny that his legacy is huge. He's often called the father of modern science, and I think he definitely deserves it. Next up, James Clerk Maxwell, the great unifier. Fast forward 2 centuries. Physics is thriving. We've got Newton's mechanics, electricity, magnetism, chemistry, and light. But they're all in their own little boxes. Enter James Clerk Maxwell, a Scottish physicist with a knack for seeing connections. In the 1860s, he pulled together electricity, magnetism, and optics into one single theory, electromagnetism. If Newton gave us the rules of motion, Maxwell gave us the rules of everything invisible. His masterpiece was the equations of electromagnetism, 4 elegant lines that unified electricity, magnetism, and light into one framework. Before him, electricity and magnetism were weird separate curiosities. Lightning, compasses, static shocks were all sort of their own phenomena. Maxwell showed that they were all part of the same phenomenon. His equations predicted that electric and magnetic fields could travel together as waves, and when you put in the numbers, those waves move at the speed of light. That meant light is an electromagnetic wave. Suddenly, light wasn't just a mystery, it was physics. He basically explained rainbows, radio waves, and the entire electromagnetic spectrum in one go. That's why some physicists argue that Maxwell's equations are even more profound than Newton's laws. But he wasn't just iconic for his equations. Maxwell was also playful. He had a knack for explaining physics with vivid experiments, like his colour wheel, where you spin red, green and blue and it looks like white, the first real demonstration of additive colour theory. Or his thought experiments, like Maxwell's demon, a tiny creature that could sort fast and slow molecules, seemingly breaking the laws of thermodynamics. It was a way of poking at the limits of physics thinking, and physicists are still writing papers about it. Maxwell was also one of the first to bring statistical physics into play. Instead of trying to track each gas molecule, he treated them more like a crowd, predicting their average behaviours instead. And that's the basis of modern thermodynamics. If you are familiar with chemistry, you might recognise this from the Maxwell-Boltzmann distribution. Maxwell's equations really say that electricity and magnetism aren't separate, they're 2 sides of the same coin, and together they create electromagnetic waves, which is what light actually is. Even more impressive, Maxwell's maths predicted that invisible waves should exist beyond visible light. Decades later, Heinrich Hertz proved it with radio waves, leading directly to radio, TV, Wi-Fi, and basically the entire modern communications world. All because Maxwell saw unity where no one else did. Maxwell himself was also a bit of a character. He loved poetry, played with word games, and apparently wrote parody songs about science for his friends. Imagine going to a physics lecture and the professor breaks out into a song about electromagnetism. To be honest, it would be pretty legendary. In many ways, he was the bridge between Newton and Einstein. Einstein himself said that without Maxwell, his theory of relativity wouldn't have been possible. That's a pretty big compliment. If Newton made the universe predictable, Maxwell made it connected. Now, for our last pioneer for today's episode, let's jump into the 20th century and meet someone who really deserves more recognition, Lise Meitner. She was an Austrian physicist, and in the 1930s, she was part of the team investigating what happens when you bombard uranium with neutrons. She was a trailblazer in nuclear physics, not to mention the fact that she was working in an era where women in science faced huge barriers. She also fled Nazi Germany. She was Jewish and worked in exile in Sweden, continuing to push forward nuclear research. Her big breakthrough came with the discovery of nuclear fission. Working with Otto Hahn in the 1930s, they were bombarding uranium with neutrons. Hahn reported a strange result. The uranium seemed to split into much smaller elements like barium. He couldn't explain it. Meitner, who was in Sweden after fleeing Nazi Germany, worked it out. She realised the nucleus wasn't indestructible. It could actually split apart, releasing an enormous amount of energy. She even used Einstein's famous E=mc² equation to calculate just how much energy this was. That was the birth of nuclear fission, the process that powers nuclear reactors and, less happily, nuclear weapons. Meitner herself refused to be a part of the Manhattan Project, saying she wanted science for knowledge, not destruction. It's why she's sometimes called the mother of the atom bomb who refused motherhood. She also famously called the atomic bomb a crime. But she didn't just stumble into nuclear fission. Earlier, she'd made pioneering contributions to radioactivity and the discovery of proactinium. She was meticulous in experiments, but also had that gift for bold theoretical leaps. Now, sadly, the Nobel Prize for Fission went only to Otto Hahn. Meitner was completely left out, despite being crucial to the discovery. Many people now consider it to be one of the greatest injustices in Nobel history, but Meitner carried on regardless. Some say this injustice was because of sexism, others because of the politics at the time, but modern physicists recognise her as the one who truly explained what was going on. Her story shows not just scientific brilliance, but also integrity. She paved the way for women in physics at a time when they were often shut out, and she helped uncover one of the most powerful processes in the universe. Meitner's story is pioneer level not just because of her discoveries, but because of the way she carried them out, under discrimination, war, and having to flee her own country. Despite all this, she still managed to carve out a place in the history of physics, and today her legacy is finally getting the recognition it deserves. So, what links Newton, Maxwell, and Meitner? Newton built the foundation, Maxwell connected the pieces, and Meitner opened up a new frontier. Each of them saw something that no one else had seen before, and they pushed physics into a brand new era. I think that's what makes a pioneer, not just working within the box, but asking the questions that create a new box entirely. I mean, all of these geniuses were once just people asking weird questions. These three scientific legends are also amazing beyond just their discoveries. I admire Newton for his perspective on science. He described himself, and I quote, as a Janussean thinker, someone who could mix and combine seemingly disparate fields to stimulate creative breakthroughs, end quote. I love this so much because I really like mixing lots of different areas of knowledge. You can probably tell from the wildly different topics I do my podcast on. I love to show that physics isn't just physics. There's a history behind it. It influences other areas of science. At points, chemistry is physics and physics is maths, and it's present in modern day culture and media. Everything is linked, and I love that Newton's attitude encourages us to have this all-round curiosity and even tells us that sometimes the best breakthroughs and most creative moments come from combining all these wonderful fields of knowledge. In fact, this is the very same attitude that allowed Maxwell to succeed. He was able to look at different ideas as a whole and connect the dots, not only seeing them as individual, separate items of knowledge, but understanding how they work together as a whole. And finally, beyond her discoveries, Meitner inspires me for her perseverance. She was a Jewish woman in a male-dominated field, something which in her time would have earned her a lot of criticism and injustice throughout her career, but she persisted anyway. Even beyond this, she resisted being involved in weapons projects, acknowledging not only the power, but also the responsibility that comes with working in nuclear science. For me, the exciting thing is that science today still needs pioneers, and I think that's an important thing to note. I find it can be easy to feel like everything has been done already. Technology is always advancing, and it's hard to imagine how certain things could possibly be more advanced. For example, every time a new smartphone comes out, I often find myself wondering, what could they have possibly done now? How have they made it even more advanced than last year's model? But at one point, smartphones were science fiction, and now they are essential parts of most people's lives. So there is absolutely more to discover, more areas to pioneer in, all building on the foundations that these scientific legends have already laid out for us. As Newton said, standing on the shoulders of giants. We think physics is done because we have equations and models, but the truth is, there's so much left unknown, from dark matter and dark energy to the very beginning of the universe. Science can also just be an endless rabbit hole. Even if we did discover one of the big mysteries today, like the truth behind dark matter, that would definitely bring up even more questions and more amazing physics. To end this episode, I really like something Brian Cox said, which I feel really encapsulates this. He said, "You dig deeper, and it gets more and more complicated, and you get confused, and it's tricky and it's hard, but it is beautiful." That's all for today. I hope you've enjoyed this episode, especially since this is a new type, this STEM history as opposed to pure science facts. I will definitely do another Legends and Lab Coats episode at some point with a new set of scientists, so stay tuned. If you have enjoyed this podcast, please go and leave a review or a comment and recommend it. If you want more Schrödinger's Chat related content, go and check out the Instagram account. You can find me at Schrödinger's Chat Podcast on Instagram. Here I post all sorts of content, from extra bits relating to episodes, science book recommendations, and just general nerdy science stuff. So if you enjoy the podcast, you'll definitely like some of that stuff, so do go and have a look. As ever, thank you so much for listening. I'll catch you in the next episode, but until then, stay curious and channel your inner legend in a lab coat. Bye!